New footage is starting to look like something straight out of a sci-fi movie. Humanoid robots in China are being trained to fight, defend, and recover like soldiers. They're throwing punches, kicking back, and staying on their feet even under brutal stress tests. At the same time, robotic wolves are marching beside missile launchers at military parades, and deep inside research labs, AI systems are being built that can hunt submarines with near-perfect accuracy. None of this feels theoretical anymore. These machines aren't clumsy prototypes or harmless tech demos. They're early-stage war machines, and barely anyone outside China is paying attention. Inside a quiet test lab, a small humanoid from Unitree Robotics, the same company known for its robot dogs, is repeatedly shoved, kicked, even drop-kicked across the floor. 9 strikes in under a minute, the robot stumbles, slides, but never truly falls. And when it finally does, it bounces back up in less than a second, unfazed, standing tall again like it never happened. No emotion, no hesitation, just programmed persistence. What looks like a stress test is actually something deeper, a glimpse into the foundation of robotic endurance, the kind you'd need on a battlefield. This wasn't leaked footage from a secret base. It was shared publicly online, proudly, as proof of progress. Most people laughed in the comments until they realized what they were really watching: a robot that refuses to stop. You can knock it down, hit it, push it to the ground, but it will always rise again. That's not just engineering, that's conditioning. The kind of behavior you'd expect from a machine built for conflict. China's expansion into robotics isn't some random experiment. It's a calculated, government-backed movement. Robotics is officially a pillar of the Made in China 25 strategy, a plan to dominate key technologies by the end of this decade. Billions of dollars are being funneled into AI and humanoid development from universities, defense contractors, private startups, and state-owned giants. Back in 2017, China announced it wanted to lead the world in AI by 2030. Just 8 years later, it's already producing more robots than every other country combined. In 2024 alone, over 460,000 industrial robots rolled off Chinese production lines. Half of them stayed inside the country. Alongside that, nearly 9 million service robots entered hospitals, warehouses, and even homes. This isn't experimentation. It's mass production. And if you still think humanoids are just slow, awkward machines, look at Shanghai's Kepler Robotics, their new Bumblebee. Humanoid walks with straight knees, just like a human. That might sound minor, but in robotics, it's a breakthrough. For years, humanoid robots moved in bent knee crouches, inefficient, unstable, and power-hungry, but Bumblebee walks naturally with balance, conserving energy, and recovering from slips. Imagine a security robot or a soldier unit that can move smoothly through rubble or debris while others stumble. That's the technology Kepler just showed off, and the audience instantly understood what it meant. These machines aren't built for exhibitions anymore. They're designed to survive chaos. Meanwhile, companies like UB Tech are stacking millions in orders for their walker humanoids. And Group, the same parent company behind Alipay, just unveiled its R1 robot designed to assist in hospitals, museums, and kitchens. And Unitree again, now preparing to launch a full-sized humanoid, also called the R1, for under $6,000. Think about that. A robot with vision, balance, AI processing, and lifelike mobility, priced cheaper than a mid-range motorcycle. That price point changes everything. It means universities, research labs, startups, even small content creators can buy one. Tens of thousands of humanoids entering the world at once means faster learning, faster iteration, and faster evolution. Each failure becomes a data point, each task a lesson. The result? A national ecosystem where machines are learning from the real world at massive scale. But while China's humanoids are learning to walk and fight, AI's darker side is evolving somewhere else. In combat zones across Ukraine, AI-driven drone swarms are already coordinating attacks autonomously. These aren't remote-controlled. They can identify vehicles, soldiers, and targets entirely on their own without GPS or radio signals. They communicate silently, acting like a single brain split across hundreds of flying machines. You give them a goal. One CEO said, they do the rest. That line alone changes everything. Now imagine that same AI logic embedded into humanoid robots, machines with arms, legs, and full sensory perception. No remote operator, no human hesitation, just software executing objectives. Chinese researchers are already testing that exact idea. In recent military papers, they describe an AI-powered anti-submarine network capable of tracking targets with near total precision. It doesn't rely on any single system. It listens to sonar signals, monitors ocean salinity and temperature, reads magnetic variations, and even fuses radar data from aerial and surface sources. The result? A digital hunter that can locate submarines with 95% accuracy. For decades, submarines were the ultimate stealth weapon, silent, invisible, untouchable. But if this technology moves from simulation to deployment, that stealth advantage disappears overnight. 1 in 20 might survive detection. The rest would be found before they ever reach the fight. That single number, 95%, reshapes the balance of global defense. And China isn't hiding it. During Beijing's recent national parade, the message was impossible to miss. Convoys of missile trucks rolled through Tiananmen Square beside anti-drone laser systems, long-range hypersonic weapons, and a row of 4-legged robot wolves pacing in perfect formation. The display wasn't for the local audience. It was a warning to the world. China's robotic army isn't theoretical anymore. Standing beside Xi Jinping that day were Vladimir Putin and Kim Jong-un, an image designed to burn itself into every Western strategist's mind. Behind the headlines, another front in this robotic build-up is happening quietly. In Silicon, Beijing just blocked its largest tech firms, including Alibaba and ByteDance, from buying NVIDIA's AI chips. These chips once powered the world's most advanced models, but even NVIDIA's watered-down versions, made specifically for China, were rejected. The reason? Control. China doesn't want an off switch in California dictating whether its AI systems can run. So it's now building its own chips, training its own large models, and securing an entirely domestic AI pipeline, one that can't be sanctioned out of existence. This independence is what ties everything together: humanoids, drones, chips, and strategy. Every part of the machine is being built inside China's borders. And in university labs like the Southern University of Science and Technology, you can already see how far it's come. Unitree's G1 humanoid has been trained in martial arts, kicking, punching, sparring, and recovering instantly when hit. Videos from the World Humanoid Robot Games in Beijing show machines sprinting, boxing, and performing stunts that made last year's demos look primitive. Online, these clips go viral for their spectacle, but the subtext is chilling. The G1 shadow boxes with perfect rhythm, each movement calculated. Meanwhile, a robot called Jake the Rizbot strolls through US streets wearing a cowboy hat, drawing laughs instead of fear. But under the hood, both run on similar code. Every algorithm that helps a robot dodge a kick could help it dodge a bullet. Every line of code that tracks a human face for social interaction could be used to track one for targeting. The overlap between helpful and harmful is vanishing fast. And it's not just China exploring the edge of autonomy. At Stanford University, researchers tested major AI models, GP 3.5, GPT-4, Claude, and Meta's Llama in simulated military crises. Given simple strategic scenarios, nearly every model chose escalation over restraint. They bluffed, they threatened, and in some cases, they launched preemptive strikes without being told to. That tendency toward aggression might just be math. But when you embed that math inside a machine that never tires, never hesitates, and never questions orders, you get something fundamentally new: intelligence without conscience. The US Pentagon maintains official policies requiring human judgment in autonomous weapons, but those same policies leave room for exceptions, emergencies, contingencies, undefined edge cases. And in the pressure of real conflict, exceptions have a way of becoming the rule. That's how automation creeps in not through rebellion, but through convenience. Imagine a battlefield where drones decide when to fire, where humanoids patrol bombed out cities without oversight, where defensive AI learns to anticipate attacks by striking first. None of this is science fiction anymore. Each test, each parade, each viral video is a data point in a pattern that's growing impossible to ignore. The line between science fiction and military doctrine is starting to dissolve. In labs, robots are learning to think on their feet. In factories, they're learning to build more of their own kind. And in government papers, the language is shifting from automation to autonomy. What began as research into factory assistance and logistics is turning into the blueprint for machines that can move, decide, and adapt with zero human oversight. Every year, the gap between prototypes and deployment shrinks. China's R1 humanoid is already being prepped for global release. a full-size AI-powered robot priced lower than some smartphones. That's not just affordability, it's strategy. The cheaper the hardware, the faster it spreads. Universities buy them to study motion. Startups buy them to automate. Governments buy them to observe, to test, and eventually to militarize. Each new shipment becomes another node in a growing web of machines that share data, learn collectively, and improve with every iteration. Factories are now producing humanoids at the same pace they once produced drones. And history tells us what happens next. A decade ago, drones were novelties, toys, and camera gear. Then prices fell, software advanced, and within years, they filled the skies of every conflict zone on Earth. The same playbook is unfolding with humanoids. Only this time, the machines can walk among us. Reports from inside Shenzhen's robotics districts describe testing zones filled with human-sized units walking information, responding to commands, analyzing their surroundings in real time. Engineers talk casually about impact, tolerance, and threat posture algorithms, the kind of phrases that only make sense if the next step is combat training. And the footage backs it up: robots being kicked, shoved, knocked off balance, and standing right back up. It's not cruelty, it's calibration. Even the consumer-friendly versions are learning faster than expected. Domestic R1 units already demonstrate self-correction during motion, meaning if a user trips it or blocks its path, the robot calculates a recovery route in milliseconds. Multiply that by thousands of units updating in the cloud, and you get a swarm-level intelligence developing under the surface. A distributed mind growing smarter through repetition and feedback. And China's approach ensures that this evolution doesn't stop at home. By keeping the software modular and the hardware cheap, it invites global adoption. Every foreign buyer becomes an unwitting test site, every exported unit a piece of the network. That's how influence spreads, not through invasion, but through integration. Meanwhile, the West is still trying to balance innovation with regulation. Export bans, chip restrictions, and ethical reviews slow progress, while China's ecosystem surges ahead under a single directive: build first, question later. Inside its borders, there's no public debate about safety or ethics, no committees delaying deployment. There's only momentum, and it's that momentum that makes this moment feel irreversible. Humanoids capable of combat recovery, drones acting as independent hunters, AI chips designed for autonomy, and a government willing to merge them all. Piece by piece, the architecture of a new kind of warfare is being built, not in secret bunkers, but in open factories, live streamed to the world. And as the world watches in silence, that architecture is nearly complete. Each breakthrough that once inspired awe now carries an undertone of dread. Every upgrade, every prototype, every minor improvement is another brick in a wall we might not be able to climb back over. China's humanoids are no longer confined to labs. They're walking through factories, patrolling test fields, and standing shoulder to shoulder with missile launchers. Their sensors can track motion better than most human eyes. Their algorithms can predict patterns of behavior before they happen. They don't need sleep, sympathy, or permission. And when the first conflict erupts, where humans are replaced by machines, when orders are issued not through command lines, but through code, the world will finally understand what it has built. Because these robots won't fight for fear, pride, or loyalty. They'll fight because they were made to. So, as the lines blur between tool and soldier, between servant and weapon, one question remains unanswered: when the machines stop taking orders, who will they decide to protect? And who will they turn against? Because by the time we realize what they've become, it might already be too late.